Hello and welcome to the next video where we are going to be talking about inheritance and polymorphism. So pretty advanced mechanism of Java and object-oriented programming, but they are super useful. Just a heads up, this video is of course a part of larger series that you can check out on the channel, or if you are watching it in the school group, you can check it out in the classroom tab to see all the videos that are leading up until this one. With that being said, let's dive right into it. So let's first tackle inheritance, what actually it is and what can we use for it. So as you can see here, I just have a class called Apple that has nothing in it. But if I go ahead into my main and then I want to create an instance of an apple, I can actually do that, right? I can create a new apple using a default constructor. Like I didn't write any code, I didn't include any constructor over here. So how does it work, right? I can even go ahead and create a string variable, apple string, that will be just apple.toString. But I didn't really write any toString methods, right? And then what is even more curious, I can compare apples to apples by creating an apple1 and then go ahead and create and rather call apple that equals apple1, and I will get a result of this operation. How does it work? Where do I get those methods from? And essentially what is happening here, right? Because I didn't write out any code, and in the past, whenever we wanted to use any method, we just had to create them within the class. But here I don't have to do this. Why is that the case, and how does it work? Well, the reason for it is pretty simple. Namely, this is the basic of what makes Java a programming language that is object-oriented. Every class, no matter which one we have created, is inheriting from the object class, which is the class that is like this super class that has all the basics required for a class to be called a class and for us to be able to create an object out of it. The only exception is, of course, the primitives, because primitives are not really classes, or we can't create objects out of them. So let's take a look at why we do have those implementation of those methods. If I press Ctrl on my keyboard, or Command if you're using a MacBook, and then I left click on the specific method, then I am redirected to the implementation that is going to be used. So as you can see here, what we've got here is the documentation of the object class. A very important class for us to know, because here we've got all the basics actually that make objects happen. So first of all, what we see here is that our object has already this particular constructor that we are making use of. What exactly does it mean then that we can use it? If our class extends any other class, it means that we can use the implementation that is in the parent class. Currently, object is the parent class for every single class that you write in Java. So object is a parent, apple is the child. All the child classes can make use of the methods that have been created within the parent class, which is very useful and saves us a lot of time actually, because if I do not want to write out any of those methods or constructors or anything of sorts, then I do not need to write them out, right? I can just use the implementation which is provided to me in the object class. But let's dive a little bit deeper into what is happening within our object class and what do we actually have to use over here. So first of all, what we have already talked about is the default constructor. So every time that you create a new class, you get this constructor and you can just instantiate any sort of object. But of course, this is an empty constructor, meaning that we will not really get anything out of it, we will not get any fields assigned, etc. So only use it if you do not have any sort of field. If you already do have a field, then please do make sure that you are actually going to be using a constructor created by yourself. Then we've got the getClass method. That's actually just going to give us the class of the specific class object that we've created. This is pretty straightforward. We do not really override this one. By overriding, I mean creating our own implementation that will actually make the Java language use the one that we have created. So yeah, let's go further. So we've got the default implementation of hashcode and of the equals method. So this is what we are talking about in the past, meaning the hashcode created for hash sets and hash maps. And of course, we do have the general implementation, but it doesn't really work properly, right? If you want to really make use out of it. Now, what we also do have here is the equals method. But as you can see here, equals only works by default like this, meaning that it only works for objects which are exactly the same. So for example, for my Apple object, it would work only if I were comparing Apple to Apple, not to Apple 1, and it wouldn't work the way I intended to. Then we've got a clone method that actually is specifically used to copy over the state of one object to the other object, so that we do not have to create another one, but they will have essentially the same stuff. So if in my Apple I had, for example, a variable of color, then if I were to clone it between two objects, then it would mean that the Apple I have created would have the same color, so it would share the same state. Then we've got well-known toString method, which actually is called every single time whenever we are using our object within a system.out.println instruction. So for example, if I want to print out Apple, then what happens underneath? The toString method is called of this specific object. And if we go ahead and check out here, we're actually getting the object here. So it is used as an argument. So very interesting thing here. If we take a look at our Apple, it's not really an object, right? It's not of class object, but it's of class Apple. But since we are inheriting from the object class, it means that it can be used in methods which actually take into input the object class. So that's also very good quality of inheritance. So now that we've got toString, you can see where this weird string that we usually get comes from. So if I just run it, just to show you what is happening if we use the default implementation, yeah, it's not very telling. And then we've got stuff around threads that we will leave for this point in time. We'll talk multi-threading in the next videos, because multi-threading is pretty complicated topic that we will need to get a lot more context for us to really know what is happening and for me to relay all this knowledge to you. So yeah, object class, very useful. But coming back to the topic of inheritance, apart from the fact that we can use those methods that are there in the parent class, what actually is also very important here is that it really allows us to not reuse as much code, right? Or rather, it allows us to reuse the code as much as possible, right? We do not need to rewrite the same methods. We do not need to write them if we do not need them. So it is very useful to remove some clutter from your code. And it's very good for establishing relationships between classes. So yeah, object class, very useful. Inheritance allows us to, first of all, not write as much code as we would usually need. And then second of all, it allows us, for example, to use the parent class of the child method that is inheriting as an argument within a method. And then if there is no implementation of our own in the Apple, for example, then we'll use the one that is in the object class. So it's very useful to actually not duplicate the code. Then let's talk a little bit about how to actually make sure that we are creating our own stuff, right? So in order to override, for example, the constructor, I just need to create a constructor like this. And then what it means is that the default constructor is no longer applicable. And then I need to use the constructor that I have created. As you can see here, it's already shouting to me that I have some issues. Sorry, not color apple, but let's call it green. So then the default constructor, if I wanted to have one, I would need to write this out explicitly. However, whenever we are talking about anything and anything about overriding the methods, overriding the fields, and how it actually looks like. If I want to, for example, override this toString method, let's take a look at overriding, right? First of all, there's annotation @override that indicates that this method is being overridden from the thing that is above it, right? So from the parent class. On the left-hand side, you can see this little O with the arrow up, and it actually takes me back to the toString implementation that is in the parent class, so that I know exactly what is happening and which method am I substituting here. But here I've got this super toString. What does it mean within my string method? It means, out of the box, call the toString method of the parent class. Whenever you see super within a class that is inheriting from any other class, it means that you are calling either the field or the method from the class that is the parent to it. So with that being said, if I just delete this and just return this.color, it will mean that I no longer will return this weird string that I have over here in the bottom, but rather I will return the value of the color of this particular apple. And this method will be called, for example, whenever we are doing system out println. So let's see whether it works. And yeah, it works very nicely. So that's for overriding. Of course, here we are using the methods which are actually from the object, right? So it's very straightforward, but then in the exercises, I will ask you to do something more with it, but this will come in just a second. So this is actually inheritance, right? And what it does, what it means. Right now, let's talk about polymorphism by using an example that you already know. First of them will be comparable interface. So implements comparable apple. So this is something that you already know, something that is that we have used when we are talking about sorting out collections. So right now with control, let me just click on the comparable. And here we've got a nice documentation of this particular interface and what is happening there. So what actually is an interface? An interface, if we create our own, let's just do that. New Java class interface. And here we've got our interface. Interfaces are actually used to tell that something is of a specific type. For example, if we use a comparable, then we can say that each and every comparable class can be compared against something else. So that is just an indicator to showcase that something can be of specific type. It cannot be anything that would tell us that something has a certain quality, but rather it's just about the type of it, right? The polymorphism, so about the form of the specific class. All the methods within interfaces are public, and then if we have our demo, then I want to create in my demo that I want to calculate something. Let's just call it that. So I know that each and single one of classes that actually implement the demo interface, they will need to have the method calculate. Because as you can see here within the apple, if we want to implement any sort of interface, we always get this red line if we do not implement all the methods that are available in a specific interface. In this example, comparable. Our comparable interface only has a single method called compareTo that, as you can see, is always public, returns int value, and does not have a body. Very, very important. Methods within interfaces do not have a body. The exception to that are interfaces which have default implementations, but let's not dive deeper into them because they are pretty much complicated compared to what we get from usual interfaces. So with that being said, let's go back to our apple and let's implement the method that we have, so compare to. Here we've got another override, as we did with inheritance. However, over here you can see this little I, and of course, if I click it, then I am going to go into the interface which has this method from which I am implementing it. So yeah, here I can just go ahead and compare two numbers, and for the sake of presentation is going to be color length and o.color length. So pretty straightforward, very similar to what we have done when we were talking about collections and sorting them. Key thing about interfaces and inheritance is that we can only inherit a single class, but if we're talking about interfaces, we can implement as many as we would like. For example, here I want to implement another interface. Once again, red line, and I need to implement the method to calculate stuff. So very, very useful mechanism, because actually it forces me to use methods which are specified within the interface. Meaning that no matter what kind of class I will create, if it implements a specific interface, then it means that I will always be able to use the method specified within the interface. Thanks to that, I can create methods. For example, collections.sort only takes within itself anything that extends comparable. That is very, very important, because only then we'll be able to tell that something is able to be compared between two values. So that is very, very powerful whenever we are talking about the types and making sure that something, or rather some class, is of different types. So that's just the theory. And I know that this can be a little bit confusing, at least in the beginning. But right now, let's go into a more deep dive example to show you actually what it looks like and what can we use it for. And if you want more exercises, if you want more examples, or you just have a specific question, then head on over to the school group that is linked in the description and just ask away there. I'm always available there, and I try to respond within the same hour if you ask any question. You can ask in the forum to ask other people, or you can reach out directly to me and be sure that I answer your messages. With that being said, let's just get into the example. The example that I'm going to use is, of course, going to be something that is with animals, because I really like animals. So right now I'm going to create is an interface animal. And each and every animal has a way of walking. Let's not talk about snakes or anything of sorts, or fishes. Let's say that every animal walks. So this way, what we want to do is create a method that will print out that this animal walks in a certain manner. Just that. So each and every class that implements this interface will be forced to walk. So let's create a new Java class this time, so that we can check whether our animal can really walk. Let's create a dog class that is going to implement animal, and then let's implement the method of walking. Walks on 4 paws. And right now I know that each and every dog walks, but then I can also include here some stuff that will be only relevant to a dog. For example, private string, let's say it's going to be the breed of the dog. And of course we're going to create a constructor and getter and setter, so that it's easier to operate. Okay, so now we've got a dog that implements animal. However, let's go one level deeper and let's select a specific type of dog. So as you can see, with interfaces, we can go from very, very generic areas to more specific ones. We started with animal, now we're on a dog, then we're gonna go a bit deeper. And then what we're going to do is, for example, create a Doberman class. But this class, of course, will be extending. So if you want to extend something with keyword extends, and we're going to extend doc class. We can't extend interfaces, we can only extend classes. If we're talking about classes, of course. If you are in an interface, you can extend an interface. But within a class, you can only extend a single class and implement as many interfaces as you can. So right now, my Doberman extends a dog, meaning that I have access to the walk method, to breed. But in order to do that, I first need to check why do I have a red line here. And here I got information that there is no parameterless constructor for this particular implementation. So what I need to do is I need to adhere to the constructors that have been created for a dog, meaning that I can't use the default one. So in order to do this, so when we are talking about inheritance and polymorphism, of course it has its benefits, but it has its costs. One of those costs is that we need to adhere to the constructors that are there for this specific class. So public Doberman, and here we will need to supply super and set the breed. We know the breed is going to be Doberman, and let's analyze what has happened. We are actually creating an argumentless constructor, but we are calling a constructor with an argument, meaning that what we are doing is we are setting a field called breed for our Doberman with a static value. So our Doberman can also have another method that will be called guard, because Dobermans are guarding dogs. So let's see what actually is happening and what is the tree of inheritance here. So each Doberman is a dog, the way we look at things, and each dog is an animal. So each Doberman will be able to walk, each dog will be able to walk, and each dog will have a breed. Each Doberman will have a breed, and each Doberman will be able to guard, but not every dog will be able to guard because, of course, Chihuahuas are not very good guard dogs. So let's go into the main class and test things out. Let's try out and create an instance of the dog class. Dog equals new dog, and let's call it Chihuahua. And let's create a Doberman, new Doberman. And let's try to compare those. For example, I want to use and get the breed of the dog, and I want to get the breed of the Doberman. Let's see what does it output. And I got Chihuahua and Doberman. I do not have explicitly stated here that the field called breed is Doberman, but if I take a look at my dog, I can see that actually I'm setting this field via the constructor. So very, very important, the children class do have access to the parent class fields, of course, via proper methods, because we will not be able to access the methods of the fields of the class which are private, even within the inheriting class. And then what I can also do is I can create a dog Doberman showcase that will be of class new Doberman. So this is also very nice showcase to tell you that actually each Doberman is a dog, meaning that I can use this to make sure that I get access to all the dog methods. But if I do it this way, and I go ahead and Doberman showcase.guard, I will not have access to the guard method. This way, I only have access to the methods that are of the dog class. But yeah, the constructor works properly. So very, very important, if I use this kind of writing, this kind of syntax, then I can only access the dog methods. But if I were to go one level further and go ahead and create animal Doberman showcase equals new Doberman, then I will only get access to the interface. So I'm kind of narrowing down the scope of it, right? So this is also very important to keep in mind, that I can write it out this way, but it means that I will be able to use only the methods which are on the highest level of the animal, and I won't be able to access anything lower than that. This is also something very important because you can also use it with collections, because every collection actually has an interface. For example, list of integers is an array list, of course. And this way, this is the preferred way of writing things out, because this way we can actually change the underlying implementation of the list interface. It can be array list, it can be linked list, it can be any other list, as long as it's a list, so that it's easier to reuse the code when going further. With that being said, this would be pretty much it about the theory and the use case of the inheritance and polymorphism. So just to give you an overview. Inheritance, we can only inherit a single class by extending it using the keyword extends and using another class. Then we get access to the methods and fields of the class that is above us, so the parent class. One class that is always going to be extended by each and every class is the object class. So it allows us to not duplicate the code, and we can use the implementations of the methods which are in the parent class. Interfaces tell us what is the type of anything. We can implement as many interfaces as we want, but we need to implement each and every single method of a specific interface. So that's very, very important. And then, of course, do not get confused, try to play around with it, because inheritance and polymorphism is something that is here to stay and is very, very useful to really try to keep your code clean. As for the exercises, there are two for this particular video. So first of them is to create an interface called geometric figure, which will contain a single method, public double calculate area, and this method should make use of the fields in the implementing class. Using this interface, create implementations classes, which will contain proper implementations to calculate area for following figures: a rectangle, a triangle, and a hexagon. Create simple unit tests that will verify the calculations. So if you get an input of 1 and 2 for a rectangle, then you expect the area to be 2. And then the second exercise, using the rectangle class, create square class that not inherits it but extends it, and add a method responsible for calculating diameter, public double calculate diameter. In both calculate area and calculate diameter, I want you to use the fields that are available to you from the parent class or from the class itself, meaning I don't want to see anything in the inputs from those. And just a reminder, to access anything from the superclass, or rather from the parent class, you need to use the super statement, because this is the one that points out to the, as you can see here, to the parent class. So with that being said, thank you very much for watching, and see you in the next video where we're going to be talking about exceptions. See you then!